Stangibelisco here, proprietor and operator of amateur radio station W1GV, Whiskey 1, Good Vibrations. You'll notice my hair is wet and I have no hat. Well, my hair is wet because I just got out of the bathtub. I took my semi-annual bath, that is every 6 months. I always take a bath every 6 months, whether I need it or not. And as for the no hat, those are all mood hats. Today I have no mood. Today I have no hat. But the point of this video is neither hair nor hats, but a particular type of semiconductor component known as a metal oxide semiconductor field effect transistor, or the acronym for that is MOSFET. Mike, Oscar, Sierra, Foxtrot, Echo, Tango. I think I got that right. MOSFET. It is a field effect transistor, of course, but of a very special type, and you can Google on that and get a lot of information about that, and the ARRL handbook and other publications also discuss its theory in quite a lot of detail. I think you may find some information about it also in my book, Teach Yourself Electricity and Electronics, any edition. But my purpose in making this video is to warn you that a MOSFET is an electrically fragile component. I expounded earlier in the previous video about how semiconductor components are electrically fragile. They are physically rugged for the most part, but electrically fragile, whereas vacuum tubes, those venerable valves of old, are exactly the opposite. They are mechanically fragile and electrically rugged. They tolerate electrostatic impulses, discharges, and transients much better than do semiconductor devices. But they don't seem to tolerate being dropped out of windows very well onto hard surfaces, as I learned as a child to my great delight with my friend Dave in Rochester, Minnesota. I expounded on that in another video as well. And one viewer pointed out correctly that that's a rather odd practice. Well, I'm a rather odd character, no lie, huh? But metal oxide semiconductor field effect transistors are so electrically fragile, for the most part, that you must be careful when you handle them. You must keep your body at DC electrostatic ground at all times. Doesn't hurt to keep your body at RF ground either, but that will automatically happen if you place a bracelet, a wrist strap, a metal wrist strap on yourself and connect that with a wire directly to a good, solid electrical ground whenever you handle metal oxide semiconductor field effect transistors. Because that little zap, and especially in the winter up north, when you touch something after shuffling around on a carpeted floor and you get this snap, it's a little electrostatic discharge. Well, even a microscopic version of such a discharge can be sufficient to destroy the innards of a MOSFET. So that particular electrical component, or any integrated circuit or other circuit that has any of those components in it, when you're working on such a circuit, you must be extremely careful, or you'll end up having to do more technical repairs than you had bargained for. That's today's lesson, other than the fact that, yes, we are going to get massive electrostatic discharges between clouds and grounds. Once again, tonight, here in the black holes of Dakota Territory, United States of abominable weather. That's all for now. Stan Gibilisco saying 73 and so long, which, regardless of the electrical component type, the frequency, the antenna type, or anything else in communications, in my native fist invariably translates to da-da-da-da-da-da.